Hi, this is Andrea Hendricks. The topic of this video lesson is inverse functions. Do you know that we live our lives performing operations? Not surgical operations, but things that we do on a day-to-day basis. And oftentimes we will undo those operations. For instance, when we open a door, how can we undo that operation? Yeah, when we close the door, right? Or what about when we drive to work? How do we undo that operation? We drive home. Are there others you can think of? Things that we do on a day-to-day basis that we perform an operation and then we do something that will take us back to where we started. Yeah, what about sitting down? How do you undo that? Right, you stand up. Okay. Now, are there things that we can perform that we cannot undo? So let's talk about that for just a minute. So if we have our operation that we performed and the thing that we had to do to undo it. I promise I'll get more mathematical precise in just a minute. So the question is, are there things that we can do that can't be undone? Yeah, hopefully you can think of some of those. You might have to take a minute, but there are lots of things that we actually do that we can't undo. Can you think of any? What about cutting paper? Can you perform an operation to get it back exactly the way it was before you cut it? No. I mean, you can put some tape or glue or something like that, but it's not going to get back exactly the way it was before we cut the paper. Or cut your hair, right? What about brushing your teeth? Can you undo brushing your teeth? No. Or cracking an egg? Or spilling your Diet Coke? Right? These operations cannot be undone. So just to kind of get to thinking about the concept we're going to talk about mathematically. So we're talking about performing operations and then undoing those operations. And we've learned just in real life, not every operation can be undone. So what is this undoing operation? What does this look like mathematically? Well, the undoing operation, and maybe I shouldn't say operation if we're talking about math, right? Let's think of that in terms of a function, right? All those operations we're talking about performing now become mathematical functions. We're going to talk about undoing that function. What does it look like mathematically? So, first off, to understand the inverse is this, the operation or function, if you will, that takes us back to the point at which we started before we applied the first operation or the first function. Okay? Like if in real life our original function was sitting, the inverse of that would be standing because it gets us back to the place where we started before we sat down. So what do mathematical examples look like? Well, let's think about adding. Is there an operation that we can perform that will get us back to what we started with before we added something? Yeah, what about subtracting? Right, if I add 2 to a number, the way that I will undo that is I have to subtract 2 from the number, right? Like let's say I start with the number 7 and I add 2 to it and I get 9. Well, what do I have to do to the 9 to get back to the number I started with? Right, I have to subtract 2. Okay, so there was my function, and then the undoing function, or the inverse. What about another operation? Well, we can certainly reverse those, right? What if we start with subtraction? How can we undo that? Yeah, adding. What if we start with multiplication? How can we undo multiplication? So if I multiplied a number by 5, the way to undo that would be to what? Yeah, divide. Or if we start with division, the thing that will undo that is multiplication. Okay, so this is our operation, or our original function, and the undoing function, or the inverse. Now, do you think every mathematical function has an inverse function? It turns out that not every function has an inverse function. Let me just show you briefly, and then we'll get into the mathematical preciseness behind this. But let's think about squaring. You might think, oh, well, square root undoes that. It does in some cases, not all. Like, for instance, let's say if I squared -2 to get what? 4. What can I do to the 4 to get back to the -2? Right, if I take the square root of 4, I get what? +2, not -2. So this one cannot actually be undone. Now there's ways around it. We can do some restrictions, and we'll talk about that later on. But what's really going on? And that's because there are actually 2 numbers whose square is 4, and we'll talk about what that's called in just a minute. Okay, so just to give you a brief background of what we're going to talk about. Now specifically, our objectives are, we're going to determine if a function is 1-to-1, and I'll explain that, using a horizontal line test. Verify 2 functions are inverses. Find the inverse of a function. Understand how the function and its inverse relate graphically, and find the inverse of a function with a restricted domain. Okay? So, determine if a function is 1-to-1. What do we mean by 1-to-1? Well, first of all, what do we mean by a function? Let's review that. A function means this: for every input, there's only one output, right? Now, if you recall, we had no restrictions on the outputs. In other words, those output values could repeat, just like if we had the squaring function. Like if we put in -2, -1, 0, 1, and 2, and we squared it, we get 4, 1, 0, 1, 4. Okay, so this is a function. But we're going to talk about that it's not a 1-to-1 function. A 1-to-1 function means this. It is a function whose y values do not repeat. Mathematically, the way we define it, we say this: if f of A is equal to f of B, then A must equal B. In other words, we cannot have 2 different x values going to the same y value. So no 2 x values can have the same y value. And that's why we call it one-to-one. Every x has to be paired with only one y. Okay, I mean that's the way we say a function. Every x has to be paired with one y, but we're saying a unique y. We're putting some conditions on what those y values have to be. So you can see that this is not one-to-one, right? Here's a y value that's repeating, and look at the x value. It's different. Well, what does the squaring function look like? If I graphed that, that's a parabola, right? So we know it's a function because it passes the vertical line test, but we're going to add another test in here called the horizontal line test. And if we do a horizontal line, look, it's crossing more than one point. Okay? So the horizontal line test says this: if any horizontal line touches a graph of f of x at more than one point, the function is not one-to-one and does not have an inverse function. So just like that parabola we just saw, if we draw any horizontal line through it, touches 2 points. So this one is not one-to-one. What about the graph of a line? Would that be one-to-one? Yeah, it doesn't matter where we draw the horizontal line. It's only going to touch one point of the graph. So that one is one-to-one. Okay? So why is it then that this function, we say, would not have an inverse? Well, that's because of what I was just talking about, that if I square positive 2, I get 4. If I square negative 2, I get 4. So if I'm trying to define a rule that will get me from the 4 back to the 2 and the negative 2, well, right there I've contradicted the definition of a function. I can't have an input value going to two different output values. And right, that's what the inverse function does. It takes that original function's output and gives me back the original function's input. But if I have original function that has the same y value, when I try to reverse that, I have contradicted the definition of a function. Okay? So only one-to-one functions will have inverses. A very, very key statement to learn. Okay? Because you got to think about this. If you know that value that results from the function operating on it, how are you going to get back to that original value that caused that action? If you can't do that, then you don't have an inverse function. Well,